Hello everyone. Myself Abdul Azim, and I am an senior iOS developer at GeeksforGeeks. So this is session number 6 of our YouTube series iOS development for beginners. And in this session today, we will be talking about custom types like enumerations, structures, and classes, etc. And so before we start today's session, let's have a recap what we have done so far, what we have talked about, what we have discussed throughout this series so far, and what we'll be discussing further later on in later on sessions in this series. So in session number 1, we have discussed about the introduction of iOS development. Like हमने बात की थी कि iOS development, what iOS development actually is. कि हम in iOS development in this domain, we will be creating apps for iPhones and iPads. And हमने बात की थी इस सेशन में like कि what is the scope in this domain, or how will you proceed to learn iOS development, क्या क्या requirements होंगी, क्या क्या requirements आपकी रहेंगी, what will be the technical requirements to learn iOS development and all. And then in the next session, we have discussed about the feasibilities or scope of Xcode, how to use Xcode, how to set up your Xcode, or how you'll be in how you'll be interfering with Xcode to to write code to develop your app. In fact, we have developed an small Hello World app also in that session. And after that, we have discussed about in our session number 3 basics of Swift, like variables, constants, operators, and data types, and etc. etc. And we have also discussed and learned about control flow in Swift, like if else statements, switch statements, loops, how we run loops, or how we iterate values in Swift, uh, like uh, like different type of loops like for in loops, where loops, or repeat while loop, etc. And while loop and repeat while loop. And we have discussed about optionals and what are optionals in Swift. Like optionals are the values which can be null or which can hold some data in Swift. And we have discussed about functions, or how to what will be the syntax of function to write functions in Swift, how you'll be calling them, how what will be different types of function calling, or what will be the different ways to pass arguments or to write arguments in functions. We have discussed about closures as well in our last session. And in this session number 6, we'll be discussing about custom types like enumerations, classes, concepts, and stored and computed properties, etc., etc. And after this session, in later on sessions, we'll be discussing about interface builders as well, like how you will be, creating UIs in UI for your iOS app. Like what is a storyboard? Storyboard is the thing where you will be, interfering with the UI elements, and you'll be creating your screens and UI for your app. And after that, we will be we will be discussing about a little deep a little deeper about UI elements like buttons, labels, text fields, etc. Or what will be the properties, what are the properties of these UI elements. We will discuss all that in that session. And after that, we will discuss about view controllers. What are view controllers? कि कैसे व्यू कंट्रोलर्स होल्ड करते हैं पूरा कंट्रोल आपकी स्क्रीन के ऊपर, जो भी स्क्रीन आप देख रहे होते हैं उसकी पूरी फंक्शनैलिटीज आप व्यू कंट्रोलर क्लास में लिख रहे होंगे. सो उस क्लास के बारे में, व्यू कंट्रोलर के बारे में हम पढ़ रहे होंगे. इस सेशन में हम डिस्कस करेंगे. And then we will discuss, or we will create some navigation based tabs, like how to navigate from one screen to another or how to pass data from one screen to another. So ये सब like in this session we will create a small app, navigation based app, in which we will create 2-3 screens, and we will navigate from one screen to another and more, and we will be passing data from one screen to another when we will be navigating them, or we will be passing data from screen 2 to 1 when we will be popping a screen to out of the one. So yes, we'll we will discuss discuss everything about navigation based ऐप के एक नेविगेशन जब आप स्क्रीन टू स्क्रीन नेविगेट कर रहे होते हो तो क्या क्या पॉसिबिलिटीज या किस किस तरह के केसेस यू कैन फेस और क्या क्या चैलेंजेस आपके हो सकते हैं, तो वो सब हम इस सेशन में डिस्कस कर रहे होंगे। एंड आफ्टर दैट वी विल डिस्कस अबाउट डाटा परसिस्टेंस विद यूजर डिफॉल्ट के कैसे आप डाटा परसिस्ट कराओगे अपने लोकल पर। अगर आपको अपने लोकल डिवाइस पर लोकल मेमोरी में कोई डाटा सेव करा के रखना है तो वो हम कैसे करेंगे, वो इस सेशन में हम डिस्कस कर रहे होंगे। और लाइक के what will be the technology stuff that we have to use to do that, to save some data in the local memory or and then fetch that data from the local memory. We'll be learning about user defaults and core data and GLM. These are some of the technologies that we have to use to save data into local memory or to fetch data from the local memory. And then we will be learning about some bigger UI elements like table views and collection views to make a list in our app, or to make grids in our app. Like if you have to make a list, you have to use table views in Swift, and if you have to make a grid, you have to use collection view in Swift. And then we will learn about how to make HTTP calls in your app, like to fetch some data from the server or to send some data to the server. कि इफ आप सारा डेटा लोकल पर सेव करा कर नहीं रख सकते जनरली एप्स में। फॉर एग्जांपल कोई भी ऐप आपकी होती है, फेसबुक, इंस्टाग्राम, जो भी डेटा आप देख रहे होते हो वो सर्वर से आ रहा होता है, दैट रिक्वायर्स इंटरनेट। तो आप सर्वर से कनेक्शन कैसे बिल्ड करते हो, क्या क्या इंटरफेस, आप वो इंटरफेस कैसे लिखते हो बिटवीन योर क्लाइंट टू सर्वर। तो दैट्स व्हाट वी विल बी लर्निंग इन दैट सेशन, कि हमें कैसे एचटीटीपी रिक्वेस्ट क्रिएट करनी है to connect with the server, to fetch data from the server, or to send some data to the server, to post anything, or to delete anything from the server. So this is what we will be learning in that session. And then we will learn how to, if we are fetching something from the server, how to pass their data in our local models, because जो हमें data server से मिल रहा होता है वो लोकल फॉर्म में होता है। तो उस लोकल डेटा वो रॉ फॉर्म में होता है, उसको जेसन फॉर्मेट बोलते हैं। वी विल बी डिस्कसिंग अबाउट जेसन फॉर्मेट एज वेल, कि जेसन क्या होता है। एंड वी हैव टू पास दैट रॉ डेटा इनटू आवर मॉडल्स। तो ये हम डिस्कस कर रहे होंगे इन दैट सेशन, हाउ टू पास डाटा जो हमें सर्वर से मिल रहा है इनटू आवर local models. And then we will discuss about App Store Connect, like how to send your app to app review, or how to uh, you know how to make your app live on App Store. So hum App Store Connect basically is a tool provided by Apple which helps you to submit your apps to a review by Apple, or then send your app or release your app to App Store. So yes, this will be the last part of this series, and this is important because after learning how to make after learning how to uh, build apps, this is important that you should know how to uh, submit your app to publish on App Store. So okay, now I think we can start with our with today's session. And before starting with the custom types like structures and classes and enums, first we will pick up one topic from our last session. That is, we were talking about functions, and so I want to discuss a little more about in-out parameter, or how to pass the reference of a parameter to the function when you are calling that function. uh, because when we pass something to the function as a parameter, basically we are passing the value type, we are passing the copy of that value. But let's say if I want to pass the original reference of that value, so that's where in-out parameter comes into play. So let me share my screen and we will see through the code how to do that. Okay, yes, my screen is visible now. Okay, so in our parameter, let's say I have two values. Let's say var a equals to 3 and var b equals to 5. Let's say we have two values, a equals to 3 and b equals to 5. And what we want to do, we want to, swap these two values. Like I want something like this. A should be equal to 5 and b equals to 3. I want to swap these two values. So let's, let's write a swap function first. Func swap values. Let's say first int and second int. What I want to do, I want to pass these a and b to this function in last. Let's say this swap values a and second b. And what I want after calling this function, my values a and b should be swapped by each other. Like the value of b should be in the a and value of a should be in the b. So to do that, if I pass directly a and b to this function, what I will be doing, I'll basically passing the copies of a and b. So if I change something in this parameter, let's say if I change something in this parameter in this function, it will not reflect back outside of the function because I'm not passing a and b. Basically, I'm not changing anything in a and b. I'm basically changing in the copies of a and b, and it will not reflect in a and b. So to make values, to make the reflection outside of the function, I have to pass the reference of a and b into that function. So to pass the reference, I have to make these parameters inout parameters. So now to call that, I will be, this is A and this is B. Now what we can do, we can simply swap these two values by the, traditional way. Let's say I have value where temp and, sorry, declare a value temp, which will be equal to first. And now first will be equals to second, and second will be equals to temp. So you see, first will be holding the value of second, and second will be holding the value of temporary variable, and temporary variable is holding the initial value of first. So now first let's say print values of a and b before swapping. So you'll see a, b, and now after calling this function, print this again, values of a and b after swapping. Now if I print this, you'll see values of a and b before swapping 3 5 and values of a and b after swapping 5 3. The value has been swapped and reflected back outside of the function because now we are changing in the parameters of the function, and the parameters of the function is not the copies of the original values. Basically, these are the references of the original values. So we are directly making changes at the references of the original values. That's why it is reflecting back outside of the function. So this is this is how inout parameters work inout parameters works in Swift. Whenever you are passing something and passing something to a function, and you are changing and you want to change that value, so you have to pass it as inout parameter. You have to pass the reference of that value, not the copy of the value, because without the inout parameter, it will be passing it as a copy of the original value, and if you make some change in that value, it will not reflect back outside of the function, basically, because parameters are value types, and you are making changes in the copies. You are not uh, you know you're not making changes in the original values. That's how it works. So keep in mind, every time when you are passing some value and you are performing some operation on that value, and you want those changes reflected back uh, out of the function, so you would have to pass those parameters as in-out parameters. Basically means you have to pass the references of the original values, and then it will be reflect back outside of the function, like we have done here. We are swapping the values of a and b. We are doing changes inside of the function, and it is reflecting back the values outside of the function. So okay, that's it for for in-out parameter. And now we will be starting our custom types like enumerations, structures, classes, and all. So let me just remove it from here. So first, let's start with the enumerations. What are enumerations or enums? Basically, enumerations are the you know enumerations defines a common type for a group of related values and enables you to work with those values in a type safe way within your code. Basically, those are model custom types that define a list of possible values. It is a type which groups the which group different kinds of same type. Like you let's say you define a enum of enum named vehicle, and a vehicle can be of different types. Like it can be a cycle, it can be a bike, it can be a motorcycle, it can be a truck, like, right? So uh, to define those types, or common type for those related values, uh, that uh, that enables you to work with those values in a type safe way within your code, or you can play with those values in a common type. So to do that, you have to define enumerations to define enums. So okay, let's create a enum and then discuss it. It will be more clear with the code. Let's say enum. This is how you let's say enum. This is the syntax to create an enum, and let's say enum vehicle, and here you can create different types, like different values of different related values, like case. First, let's say cycle, let's say bike, let's say car. So these are different kinds of vehicles. So this is why you create enums, to define different uh, kinds in a same type. Okay, to define uh, different related values in the same type, in the same group. So this is how you create enums. And let's talk about how you can play, or how you can play with the enums. Let's say for every vehicle, I want to I want to print the description of the vehicle. So let's say, let's write, you can run a switch statement over enums, and switch statement will will let you handle every case in in the switch statement, like switch. Let's say first create a value, let my vehicle equals to vehicle dot give it a value, let's say cycle. And let's say this is my variable, my vehicle, and I want to print the description of the vehicle. Let's say switch my vehicle case dot cycle something case dot bike something case dot car. So in cycle, let's say I want to print this is two-wheeler without any motor. Okay, and let's say if for bike I want to print this is a two-wheeler with motor. And let's say car, this is a four-wheeler with motor. This is a four-wheeler with motor. Sorry, print print print. Now let's execute it and you will see this is a two-wheeler without any motor because my vehicle value is cycle for now. Let's change it to, let's say, bike, and you will see if I execute it, you'll see this is a two-wheeler with motor because this is bike. And let's say I put it car and print it. It will say this is a four-wheeler with motor. See, so this is how you can process an enum type. So let's, you can also define or create a type of the enum, like it will be my vehicle will be a vehicle type and its value would be, let's say, car, like this. Now let's do something, let's do some more, and instead of creating running switch statement uh, outside of the enum, let's put it inside. Let's say var create a computed property inside the, we'll be discussing about stored and computed properties and in this session after the after discussing structures and classes. Let's say var description it will be of a string type, and let's run the switch statement here. Or let's say let's switch self. Switch self means we are running the switch statement on the self type, on the vehicle type, on the cases, on the different cases of vehicle type. So case, let's write down the cases: cycle, case bike, case car, and return two-wheeler without motor. For bike, let's return two-wheeler with motor, and then let's write four-wheeler with motor. Four-wheeler with motor. Now, when you create an type of the enum vehicle, or when you create a variable or constant anything of vehicle type, then you can directly access the description of that type of that case. Like I have declared here, I have defined here my vehicle, and uh, we have declared it with initial value that is car, and now my vehicle dot description. If I do this, you will see it will print the description of, you know, I missed a colon here. You will see if I print this, you'll see four-wheeler with motor because this is a car. So this is how enum works. This is how you can play with enums. You can also provide some raw values to enums. Let's say I say this will be of string type, means the values of these cases will be of string type. Let's say cycle, or let's say raw value will be of integer type, and I put, let's say identifier of the cycle will be 0. That is, its value will be identified by 0, bike value will be identified by 1, and car value will be identified by 2. And now if I print my vehicle dot raw value, and you will see for car it will print 2. See, this is 2. And if I change it to cycle, it will print 0. See, 0. So this is how these are the some specialties of enums. That's how you can work with enums. That's how you can play with enums to work around. Okay, now let's jump to our next session, next section, that is structures and classes. What are structures and classes? So basically, structures and classes are the custom types that are general purpose flexible constructs that become the building blocks of your code, of your application. So basically, these are the model custom types that lets you encapsulate data and provide some functionalities to play with that data, or to perform some operation on that data. These are basically the blueprints of some custom type that you're going to define, which will be encapsulating some data and which will be providing you some functionalities to perform some operations on that data. Okay, so let's go beyond and see how what is the syntax to basic syntax to create structure and classes. So basically, to create a structure, you can just write like this, my structure, and these are you are creating types here, custom types here. So by the rules of language of Swift language, a type will be a upper camel case type. That means the first letter, it will be a camel case type. You will write the name in a camel case style, but the first first letter will not be small letter, it will be a capital letter. So my structure, we call it capital camel case style. This is how you create a structure. And same like this is how you create a class. So this is the syntax to create your structure, or to create your class. And now let's let's move on and see how you can create the instances of structures and classes. Let's say this is my structure, and I'm saying let property, let's say value 1. This is a structure which is having uh, two properties, value 1 and value 2. Let's say this is of type integer and this is of type integer. And let's say my class. Let's say value. First stop there and let's create an instance for the structure. So let structure object or instance equals to my structure and value 1 and value 2. You see, we haven't defined an initializer or constructor inside the structure, but it is still giving us the way to create some, to create the instance of the structure with some initial values. So that's how, uh, structures provide default initializers or default constructors. Matlab, this is the one way structure is different from class. Class cannot give you. We will be discussing it with when we'll be creating the instance of the class, but class does not provide you default constructor. So let's say I say value 1 1 and value 2 2. So this is how you can create the instance of any structure. Now let's create let value 1 int, and now if we want to create the instance of the class, let class object equals to my class. So see, it is not providing us any any constructor in default constructor, or to it is not giving us any way to create the object of that class with some initial values. So what we can do, so we cannot create the instance of the class the same way as we have created for the structure. So we have to provide initializers. Like in the error, it is saying class my class has no initializer, so we have to create an initializer. So let's say init value 1 int value 2 int and self dot value 1 equals to value 1 and self dot value 2 equals to value 2. So now if we call my class, see, now we are getting uh, getting a way to create the instance with some initial values, because we have provided the initializer to the class now. So now if we have, like, let's say 3 and 4. So this is how you can create the instances of you can create the instances of structures and classes. So now let's move on to the next type, that is value type. Structures are basically value types. That means if you create an instance of an structure and assign it to the next value, so it will basically be passing the copy of that first instance. Now you will be having a copy of that same instance. You will be having two instances instead of one. So let's say I if I create let, first let's see, let's make it var. let's say if I create a structure object 2 and initialize it with the initial object of my structure, that is structure object 1. Let's say structure object 1. So 1. Now if I change something into the structure, now these are the same instances, right? So now if I change something in structure object 2, let's say structure object 2 dot value 1 equals to 10. Now print first instance value, that is structure object 1 dot value 1, and then we print second instance value structure object 2 dot value 1. And now if we print this, you will see first instance value is 1, second instance value is 2. What we have done, we have changed the value of value 1 property of structure object 2, and it is it isn't reflected in into object 1, into structure object 1, जबकि ये दो हमारे सेम ही इंस्टेंस हैं। हमने एक इंस्टेंस क्रिएट किया था ऑब्जेक्ट 1 एंड हमने वो सेम इंस्टेंस ऑब्जेक्ट 2 को असाइन किया। हमने कोई नया इंस्टेंस क्रिएट नहीं किया, बट जब हम इंस्टेंस 2 में चेंजेस कर रहे हैं वो इंस्टेंस 1 में रिफ्लेक्ट नहीं हो रहे हैं बिकॉज स्ट्रक्चर्स आर वैल्यू टाइप। व्हेन यू पास वन वैल्यू टू अनदर, you are basically creating copies. You are not creating the same reference. You are not passing the same reference. So when we have assigned object 1 to object 2, basically now we have a copy of object 1, that is object 2, and now we are changing values on the copy of that object. We are changing values on the object 2. That's why that will not reflect into the object 1, because every time you pass one object to another of a structure type, of a value type, it will create a copy instead of passing the same reference. So you do anything into the one object, it will not reflected back into the another object. So that's how value types work. Now let's move on to reference type. That is, classes structures are value type and classes are reference type. So let's say now if I create var class, let's put it 1, class object 1, and now class object 2, and pass it class object 1, and now change something into the class object 2 dot value 1 equals to, let's say, 11, and now print the instance values. That is class object 1 and that is class object 2. Now if we print this, let's see what happens. You will see the first instance value is 11 and also the second instance value is 11, though we have only made changes in object 2, but it is reflecting back into the object 1 because classes are reference type. When you are assigning one instance to the another, so you are basically not creating any copy or not creating any other object. You are creating the same reference. That means object 1 and object 2 now will be referring to the same instance. You are not creating more than one object. You are creating just same reference. You are creating two reference to the same instance or same object. So you do anything with any object, you change anything in any object, it will reflected back into other objects if they are if they are referring to the same instance. So that is how value type and reference type works. So let's jump to our next thing, that is identity operator. So basically identity operator works for the reference type. It is to check if two uh, referring to the, or two object referring to the same instance of a class type. Let's say if I want to check if object class object 1 and class object 2 referring to the same object or not, so how I will do that? So that's what identity operator, you know uh, that's what we use identity operator for. Identity operator. So basically what we can do, class object 1 triple equals and class object 2. So print they are referring to the same instance. See, they are referring to the same instance. See, so this is to check if two objects are not referring to the same instance, or two references are not referring to the same instance. So let's what we have done here in object 2, now we have created another object of my class. We are not assigning it to the object 1, we are creating a new object. And now if we print this, you will see it will say they are not referring to the same instance because we have created a new instance for object 2. Okay, that's how identity operator works. So now if we come to a a comparison of structures versus classes, or a comparison between structures and classes, what are the differences between those? So first difference is, of course, structures are value types and classes are reference types. And what are those? We have already discussed what is a value type, what is a reference type, or how those two things works actually in your code. So first thing is, structures are value types and classes are reference type. And second thing is structures you know, are lightweight, are so lightweight. That's why, and structures provide you default initializer. So let's just put here structures are value types and classes are reference types. Structures provide default initializer. Structures is basically not holding any reference to the memory. It is just, working on the values. So structures are lightweight and thread safe. And thread safe. And the another one is, structures cannot leverage oops concepts like the inheritance. So, to uh, that's why most of the you will see in the future when we'll be writing some more code for the apps, when we'll be building some models, you will see most of the time we will be using structures. We will only use classes uh, when we have to explicitly use those concepts like inheritance and all, because structures are lightweight and thread safe. That's why most of the time we will be using structures. जब तक हमें क्लास की स्पेसिफिकली जरूरत ना हो, उसका कोई स्पेसिफिक यूज हमारे पास ना हो, लाइक हमें इनहेरिटेंस यूज करना है, अदर उस कॉन्सेप्ट यूज करने हैं, सो तब तक हम क्लासेस यूज नहीं करते हैं. दैट डजंट मीन कि यूज नहीं कर सकते हैं, यूज कर सकते हैं, but structures are more flexible to work with. They are easy, they are lightweight, they are thread safe. So that's why we will be using structures most of the time until and unless a class is needed. Okay, so these are some differences between structures and classes. Now let's move on to our next section, that is properties. What are properties? Basically, stored we will be discussing some properties like stored properties, computed properties, lazy properties, instance and type properties. So what are stored properties? Basically, stored properties are constant and variables which stored some value. Like for example, let's say I write property equals to, let's say this is of type int 0. So that is a stored property because it is directly storing some value. It is directly storing some value. Here it is directly storing integer, that is 0. So that is a stored property. It should be of it can be of any type like a string, and you can put some value here, let's say some value. So this is stored property. It is storing something. It can be of constant, it can be a constant, it can be a variable, whatever. So it is a stored property. Now, let's say you have a, let's say we have a structure and we have a stored property. For example, this, we have a structure, my structure, and we have a stored property here, let's say 0, or let's say 1. And now if I create some instance of that structure, that is, let's say let, I'm creating a constant instance, that is let. So my instance, that is my structure, and I'm not providing any initial value because we have already provided some initial value. If we'll not provide some initial value from that side, it will be initialized with those values that we have, we have assigned inside the structure. So now let's say if I do this, my structure, my instance, basically my instance dot value 1 equals to, let's say 3. So you see, it is throwing an error because it is saying cannot assign to property. My instance is a let constant. So value 1 is a var property in this structure. You will see this is var property, but I have created a constant instance. So in fact, the value is the property is a variable, but we cannot change it because because the parent, because the instance is constant, so we cannot change it. Though the scenario is different in class because class are reference type. So if I create here, let's say my class, let's say if we provide my class, let's say 1, let's say 2, you see there is no error when I have created an instance for class and we have changed the value 1, though the instance is a constant type, let. So, but we are still able to change it because the classes are reference type. So that is also the difference. If you have a stored property in a constant type of a value type, you cannot change it, if even if it is a variable. But if you have a if you have a variable property in a constant instance of a reference type, you can change it. So now, what is a lazy property? A lazy property, basically, you can create it like lazy var lazy property. This is 0. So lazy property are the property which can, which will not be. Okay, because we have not, defined it inside a type, inside a structure or class. So anyway, so let me define it. A lazy property is a property which can, which will not be initialized until and unless it will be used first. So if inside a class or a structure you have defined a lazy property, let's say some property equals to 0, and when you create the instance of that structure or class, the property that you have defined lazy will not be initialized. It will only be initialized when you access that property or when you will be using that property. So that is the difference between normal and lazy property. When you have created an instance, you know when you create some instance of a class or a structure of a type, all properties will be initialized at the same moment. But if you have a lazy property, it will not be initialized until and unless you have accessed it. After creating that instance, you have used it somewhere, so it will only initialize when it is first used. Until and unless, it will not be initialized. Okay, now let's see what are computed properties. So computed properties are something which are in which you are not storing any value, but every time you are accessing those values, you have to calculate something. You have to calculate something. Like, let's say if you have a structure, struct circle, and you have, let's say, radius, that is, let's say, int, or let's say square, and you have a side that is of int type, and let's say you have another property that is area. So you see, side is an stored property. When you will create an instance, you will pass some side of the square, and it will be stored inside the side. So let's say area, and I say int return, and you will return side into side. So basically, you are not passing some value of area from the outside. What you are doing, basically, let's create an instance. Let's create let my square, and let's put it square side, let's say 2, of length 2 centimeter. So what you are doing, and now we have not provided any value to area from the outside, right? So now if I access the area, my square dot area, you will see we are seeing the, okay, let me just comment it. You see, uh, uh, there is the value of area 4, though we have not provided any value from the outside. So what it is doing, side is a stored property. We are providing the value of side from the outside, that is 2. And when we create the instance of the square, what it will do, it will compute the value of property area. So it is computing the value of property area on behalf of the other property, that is side. So this is a stored property, and this is here a computed property, because it is computing the value. It has you know it doesn't have a constant or variable value is directly stored in it. It is computing the property of area on behalf of side. What side is coming from the outside? Let's say if I pass it 3, so it will print 9. The area of a square will be 9. So it is computing it every time. Every time you are creating an instance and you are providing some value to side from the outside, it will be creating some. Uh, it will be computing the property of the area. Let's say I have changed the first. I have created the square with side equals to 3. Now I'm changing the length. Let's say square my square dot side equals to, let's say it is 5. And now so you'll see two values. First, when you have created the instance with side value equals to 3 and you are accessing the area, you will see the area value will be, when you are accessing the area, it will compute the value of area, and it will print, it will calculate the value of area on behalf of side equals to 3, side value equals to 3. Now we are changing the value of side equals to 5, and now if we are accessing the if we access the value of area, what it will do, it will compute it again with the new value of side, and it will return us the new value, that is 25. So I guess that's it for this session today. And we'll be discussing instance and type properties and property observers in our next session. And for some time, we are here if you have any question, so you can drop that into the comment section. Okay, we have a question here. Why we use structures to create model? So, of course, we will be discussing that in detail in our later on session. But for brief, I can tell, like structures, there is no need of using class there, because we are not using any OOPS concept like inheritance there. And second, structures are easy to use. And as I have said, structures are lightweight and thread safe. So you, of course, you can also use classes there, but like I said, there is no point, because you are making it we are making it complex. There is no such need, explicit need to use classes there. So why go for, that's why we can use both structures and classes, but we go for structures, because there is no explicit need of class there, because we are not using leveraging anything extra that we can find only in class, like inheritance and all. So there is when we create models to parse our JSON data or anything to parse our local model, we use structures, because there is nothing that we cannot find in structures. For that we have to go to the classes. So we use structures because they are lightweight and they are thread safe. So yes, until unless there is an explicit need, जो चीजें हमें क्लासेस ही प्रोवाइड कर सकती हैं, until and unless ऐसी कोई नीड नहीं है, तो हम we don't use classes, we use structures, because they are safe to use, they are easy to use. So I guess there is no any other question. And okay, thank you guys. Let's meet in our next session.